Welcome to Daring Maranda YouTube channel. Oh, my Sri. Today we will be discussing about coefficient of forms and its significance. These coefficient of forms are used to understand shape, configuration of ship, dimension of ship, etc. These are used to understand have a dimension of ship, configuration of ship, and shape of ship. Basically, this is a dimensionless quantity. There is no unity for it. It's a dimensionless quantity. Then waterplane coefficient, CW. Waterplane coefficient, it is the waterplane area divided by multiplication of length and breadth. That means CW is equal to AW divided by B into L. Means, like I mentioned, AW equal to area of waterplane, B breadth, L length. Here high waterplane coefficient indicates good stability and good maneuverability in rough condition, and it will provide high friction resistance. When coefficient of waterplane or waterplane coefficient is less, it indicates low friction resistance and fine ends. Then we can say midship coefficient or CM. It is cross-sectional area of underwater portion of midship section to the product of breadth and draught. That is CM is equal to AM divided by breadth into T. That means AM means midship's cross-section area of immersed portion, B breadth, T draught. This midship coefficient gives an idea of ship at midship. These cargo vessels having boxy shape at midsection because of high midship coefficient, whereas sailing boats will have low midship coefficient. Cargo vessels will have boxy shape in the midship section, but here in the boats and all there will be midship section coefficient will be very less. Then block coefficient. It is the ratio of volume displaced by ship to the product of length, breadth, and draft of immersed portion of ship. That means CB equal to delta divided by LBT. That means delta is equal to volume of displacement. Then L equal to length of immersed portion, B breadth of immersed portion, T equal to draft. Underwater volume of ships are calculated using block coefficient, because underwater volume mainly the immersed portion of length, breadth, and draft are measured using this block coefficient, because usually tankers having high this block coefficient, whereas passenger vessels will be having low this block coefficient. Then prismatic coefficient. It is the underwater area divided by the area of midship section to the length of ship. That means CP equal to delta divided by AM into L. Here delta means volume of displacement, AM equal to area of immersed portion of midship section, then L equal to length of midship portion, length of immersed portion. So prismatic coefficient means it is the underwater area divided by area of midship section and the length of ship. These are the main dimensions regarding the shape of ship. Then let's see the relation between prismatic coefficient, block coefficient, and midship coefficient. So when we say the relation means block coefficient will be equal to the multiplication of prismatic coefficient and midship coefficient. That's the relation between CP, CB, and CM. CB equal to CP into CM. So, thank you.